Hello learners, welcome to this session. This is a session on dimensional modeling and star schema of MCS 221 data warehousing and data mining unit 3. So this is the sixth session in this series. Earlier we had discussed the basic aspects of the data warehousing, and then we had in the previous session we had seen the data marts and its functionality. So in this session, let us concentrate on a very important technique, that is the dimensional modeling. So the basic objective of this particular session is introduction to dimensional modeling, reasons for dimensional modeling, elementary measures to build a dimensional schema, facts, dimensions, fact table, dimension table, star schema design with some examples. In the databases, we had heard about three types of database modeling, like the relational modeling, the hierarchical modeling, and then the network database design model. So these particular models may not suit the needs of the data warehousing. That too with the perspective of modeling the complete data which is in various forms and formats. So here you require a different kind of modeling technique called as dimensional modeling. So this is a technique used in data warehousing and business intelligence to design and organize data structures that facilitate efficient reporting and analysis. You can see here already the data is available in various formats, but we have to convert it into a kind of centralized repository. That too it consists of huge records. Not only the relational records or else the flat databases, however the data may be coming from various sources also. So the basic need that we have, the basic insight that we are getting from the data warehousing is the complete reporting and the analysis mechanism. It provides a way to represent and organize data in a manner that is optimized for querying and understanding business processes. So this is the basic technique wherein which the dimensional modeling comes into picture. So the data warehousing, which consists of a huge repository of data. So querying against that particular data is a huge task. Until and unless you have a good modeling technique, you can't do efficient querying or else optimizing querying and derive them in the form of the reports. So let us see the goal of the dimensional modeling. The basic goal is to create a logical and intuitive representation of the data that aligns with the how users think. So this particular dimensional modeling is very much nearer to the human thought process. So maybe in the relational schema, you have to find out the entities, the kind of relationships, the kind of weak entities, strong entities, once again the cardinality. Most of the things comes into picture, but here it is very near to the human thought process about their business processes, and the questions they want to get the responses from the data warehouse. So this is the basic goal. And then it emphasizes the use of business concepts such as dimensions and facts, which we are going to read in the next few slides, to model the data rather than focusing on the underlying technical implementation. We may be like being the user who wish to generate the reports against the data warehouse. You are very much interested in the kind of reports that I wish to generate other than the technical details behind it. So need for the data dimensional handling. As I told you, there are three types of databases which are very much popular, like the relational databases, networking databases, and then the hierarchical databases. The need for dimensional modeling arises from the challenges of analyzing and reporting on complex and large scale data. So it is not just some GB of data. it may be running to terabytes of data or else even further. So analyzing that particular the huge data from the repository and reporting on complex and large scale data using the queries is a Herculean task. So it provides a structured and optimized approach to organize data for analytical purposes. And then this particular and later on it will derive the valuable insights from them. So there are certain reasons. We had just seen the goal and the need. There are certain reasons, technical reasons also behind why we can't do all these things using the relational database system or else a network database system. But there are few reasons which strongly recommend this dimensional modeling as the modeling technique for the data warehousing. So one of the technique is this particular dimensional modeling simplifies the data analysis part because it is a denormalized technique, and then it is a technique wherein which it completely very much nearer to the human thought process. That too, the business, all the business processes will be covered, and then it supports the business understanding. That is the basic reason which we one of the basic reason which we recommend the data dimensional modeling for the data warehouse design. Then it improves the query performance. It enables the ad hoc reporting and analysis, supports data integration from various resources, not only from a single resource, which may be a flat table or which may be a relational database itself. However, it supports many variety of data into its data repository. And then it provides adequate scalability, extensibility, flexibility, and also it enhances the data quality, and for the governance also it is very much easy to have this technique. So there are two different elements which would take care of the whole dimensional modeling. One elementary measure is the dimension measure, and the other elementary measure is the fact measure. So dimension measure is nothing but it represents a category or perspective by which the data is analyzed. It means that it totally captures the descriptive attributes of business entities or objects and provides the context for analyzing the measures of metrics in a data model. So dimensions are typically represented as tables in the star schema or snowflake schema, which are the two different representations of the dimensional modeling. So you'll be understanding by looking into the examples. Let us take the case of a time dimension. Time is one of the dimensions we can consider, and then this is a kind of measure which is used to analyze data over time periods. It may be hourly, it may be day-wise, it may be week-wise, it may be month-wise, whatever the thing that you put as a fundamental thing. So the time dimension is one of the dimension which we can measure, or else from which perspective we can analyze the data. It includes certain attributes like the date, month, quarter, year, half yearly year, year-wise, or else 5 years, whatever the thing that we consider, the hierarchical relationship between these attributes can be formed in order to analyze or in order to get the insights into sales performance over some different months or else different days or different years. All these things can be considered. The second dimension we can talk about is the product dimension. So the product dimension describes the characteristics of the products or services being sold. So it may include the product name, category, brand, stock keeping. So by category, we can once again analyze and find out, or else find out the insights. Or else by stock keeping unit, you can, through this particular dimension, you can once again find out the insights. Or else even by the brand. Also, we can get the, we can run the queries against that dimension and we can get the insights from it. Or else there is another dimension which can be considered is the customer dimension. So it may be considering the customer ID, name, address, demographics, and other customer related details. Maybe the state where the purchases are more from those customers. That too with respect to some brand. So these kinds of things also we can consider as the dimension. And then geography dimension is one example we can give. That geography dimension represents the geographic attributes relevant to the business. It includes the attributes like the country, the region, the state, the city, the district. So all these things can be considered as the attributes and can find out the insights. Employee dimension is one such criteria or example wherein which we can capture information about employees, individuals associated with the organization. Then there is another important measure, that is the fact measure. In the fact is nothing but it represents the numerical measurements or metrics. Earlier we had seen when we were talking about the dimension, we were talking about the attributes. But here we are talking about the numerical measurements or metrics that are being analyzed in a data model. Like for example, the fact table consists the quantitative data and the answer specific business questions or represents events and the transactions. Let us see and understand with the help of the examples that we had quoted over here. One is the sales revenue. So sales revenue may be one of the fact. So it can be measured in terms of the sales revenue can be measured in terms of amount that we are getting in that shop or in that superstore. So sales revenue is a fact that represents the monetary value which is in numerical form of nature, generated from the sale of products or the services. So here we are just considering the numerical value. Fact is numerical value, and here the sales revenue is nothing but the monetary value that we are going to calculate. So it is a typical measure. It is typically measured in a specific currency and can be analyzed across different dimensions. So this particular sales revenue we put across the dimension. Like time can be one dimension. It's like what kind of sales revenue was generated for a particular product. So there also we are calculating the monetary value. Customer is one particular thing. Like age may be one particular dimension. Geography may be one particular dimension. By analyzing sales revenue, businesses can gain insights into their revenue performance, identify top selling products, or else they can see they can measure the sales growth, or else they can compare the revenue across different regions, or else they can compare the revenue across different geographical factors. So all these things are possible. The second example that we can quote here is the units sold. So units sold is once again a numerical value. So units sold for a particular brand. Here we are once again using the dimension. Brand is a dimension. So units sold is a fact that represents the quantity of products or services sold. It measures the volume or count of items sold that and can be analyzed across dimensions such as time, product, customer, once again the geographical factors. So this is another example that we can quote here, and the insights can be found for a particular product demand over time, or else we can evaluate sales performance by customer segments. All these things are possible by having the units sold as the fact. And the third example that we can quote here is the profit. Once again, it is a numerical or monetary value, and that represents the financial gain and obtained from the business operations. So this can be analyzed against some dimensions such as time, product, and then customer, geography, to gain insights into profitability trends, or else identify which is getting the highest margin in case of profit, measure profit growth over the time period, or else evaluate the profit contribution by different customer segments. So these are the possible kinds of insights that we can have with the profit as the fact, and time, product, customer, and geography as the dimensions. And then there is another thing that we can consider is the click-through rate. Obviously, this particular click-through rate is a kind of advertisement, digital marketing kind of criteria, wherein which this fact commonly used in digital marketing and advertising. It measures the ratio of users who click on a specific link, even though that is viewed by several users. However, how many people are clicking on that particular link after the view? So a specific link or advertisement to the total number of users who viewed it. So CTR can be analyzed across dimensions such as time, campaign, placement, target audience, to assess the effectiveness of marketing campaigns, or else to assess or else to compare CTR performance across different channels, or optimize advertising strategies. So these are the kind of possible insights when we consider the click-through rate (CTR) as the fact. And then call duration. So call duration is a fact used in a call center analytics. So it represents the length of time for customer calls or interactions. So this can be analyzed against some dimensions like the time, agent, customer, call type. So these are certain dimensions which against which we can analyze, and then maybe getting the insights like identify long duration calls, short duration calls, or else the agent's performance, or optimize call handling processes. So these are certain kinds of insights which can be watched by having the call duration as the fact against certain dimensions. Then comes there are, even though we call dimensional modeling as a technique, there are three types of schemas which can be having a prominence in the dimensional modeling arena. So one is the star schema, second is the snowflake schema, and third is the fact constellation schema. So third one is a kind of hybrid kind of thing, but first one is the star schema is very much popular among the dimensional modeling designers. So in this particular star schema, it is nothing but it is having the appearance of a star. Like symbolically, it is having the appearance of a star. The star schema is widely used modeling technique in dimensional modeling, and it represents a simplified, that to very nearer to the human thought process for organizing data in a data warehouse or else in a data mart. So this consists of a fact table which is placed at the center, and then many dimensional tables which are surrounded for that particular fact table, and it gives a kind of star appearance when we place the fact table and the dimensional table surrounding it. So hence that particular name of star schema is being given to the dimensional schema. So the key components of the star schema are, one, I told you, that is the fact table which will be placed in the central position. Then there are various dimension tables which will be having the primary keys inside the fact table, that we call it as the foreign keys, and then primary keys and the foreign keys, denormalized structure, aggregation and summarization. So these are the things that are the key components whenever we wish to design the star schema, the dimensional modeling star schema. So fact table is nothing but the fact table is the centerpiece of the star schema. It contains the quantitative measurements, as we had already seen. I had given you certain examples also, units sold, etc. So those are being analyzed, such as sales revenue, units sold, profit, whatever the case may be. So each row in the fact table represents a specific event, transaction, or the measurement. The fact table also includes foreign keys that establish relationship with the dimensional tables. So within the dimensional table, one key is identified as the primary key, and that key will be placed in the fact table in order to have a kind of referential kind of entity. So that particular foreign key is placed inside the fact table for each and every dimension table, other than the facts that are placed towards the below end of the fact table. We will see the example also how the fact table looks like, or else how the dimensional table looks like. Then comes the dimension. Then the other key criteria is the dimensional tables. So these dimensional tables provide the context and descriptive attributes for analyzing the facts in the fact table, maybe time bound, maybe geography, whatever the maybe brand, maybe whatever the case may be. So all these things form as a kind of dimension to the fact table given, and each and every dimension table consists of one particular primary key which will be referred in the fact table as the foreign key. So each dimension table represents a category or perspective dimension by which the data is being analyzed, like the time or product or customer or geography, whatever the case may be. Each dimension table has a primary key that is referred as a foreign key in the fact table. So all these particular structures are denormalizer structures. So the star schema follows a denormalizer kind of structurization where each dimension table is denormalized to eliminate the redundancy, and which may be helpful in having a simplifying the querying process also. So it is not a kind of normalized structure wherein which in case of relational databases we follow the normalized structure in order to remove the in order to avoid the redundancies and other kinds of things. We were having 1NF, 2NF, 3NF, BCNF. So likewise we have several normal forms wherein which the tables are being derived into a particular normal form, and then we will be having the database design. But here each and every dimensional table we have the denormalized structure. So the denormalized structure facilitates efficient and fast retrieval for reporting and analysis process. So that is the primary reason which we wish to have the denormalized structures in the dimensional tables. Then comes the aggregation and summarization. So the fact table in a star schema is typically designed to store aggregated and summarized data at different levels of granularity. So this is the basic thing that one needs to understand with respect to the aggregation and the summarization. So each and every fact table is not a detailed table. However, typically the whole thing is been aggregated in the form of a fact table and summarized data at different levels of granularity. So aggregation involves summarizing the facts based on different dimensions such as by month, product or customer, and this pre-aggregation of data enables faster query performance when analyzing data at different levels in detail. So benefits that we are getting from the star schema is it is very much simple in nature and intuitive structure for data analysis. When comes the benefit that we are getting from the performance criteria, it improves the query performance in many times. And then coming to the flexibility part, it supports ad hoc querying and analysis. So both the things are possible when we design the dimensional modeling using the star schema method. And then scalability. So it allows addition of new dimensions whenever the business processes increases and it requires some sort of additional requirements which were not foreseen in the previous design. So we can include those particular business requirements, evolve or else enhance the dimensional model using the star schema, include more dimensional tables, include more things in the factor table also, which may be making it a kind of scalable and also the adaptable in nature. So designing process. So we had come across all these things and how to design the star schema. So identify the business processes first of all. So what kind of business processes are completely involved, against which the queries are possible, or else against which the insights are possible, or for the databases those are existing, and then identify the dimensions. So among which either it may be a time dimension, whether to have the dimension called as geography dimension, whether to have a dimension with respect to the selling kind of thing. So all these dimensions we have to visualize, and then identifying the facts. So these are the numerical items or else the monetary value that needs to be considered, and then put it as the fact. And later on define the dimension and the factor tables. So we had identified the dimensions, we had identified the facts, and then we have to form the fact table wherein which it consists of the keys, those are being referenced by the dimensional tables, as well as the facts, those needs to be addressed to. And then we have to establish the relationships, to which relationship among the dimension tables, and then denormalize the dimension tables, aggregation and summarization for in case of the fact tables, validate and refine and implement the schema. So this is the complete design process to be followed whenever we wish to have the star schema kind of dimensional modeling. Let us see one simple example over here. This is the example for a star schema wherein which you can see within I had already discussed that this particular schema itself is a kind of giving the appearance of a star, wherein which the fact table is placed in the middle, and then the dimension tables are surrounded by. So here you can see when you take the product dimension, the product, there is one particular primary key for each and every dimension table. You please observe there is a primary key for each and every dimension table. Here in the product dimension, you have the product key as the primary key, which will become the foreign key in the fact table. So whenever there is a relationship between the fact table and the corresponding dimensional table, then you have to have the primary key of the dimensional table as the foreign key in the fact table. You can see here, you have the product key over here as the second item in the fact table. And then for the customer dimension also, you have customer key as the primary key. Other than other keys, you have customer name, purchase profile, credit profile. These are the attributes that the customer dimension has. And then promotion dimension also has certain columns. So promotion key is the primary key, which is being referred in the fact table. So likewise, time dimension, store dimension, and clerk dimension. And then once again, after identifying the facts, after identifying the fact table, after identifying the dimension table, establish the relationship. So we had established the relationship wherein which we had identified the primary key, and we had placed that particular primary key as the foreign key in the fact table. So a relationship among the fact table and corresponding dimension table is being established over here. And then you can see here, other than the keys, those are being taken or in the form of a foreign key in the fact table, sales fact table. There are three other items, that is dollars sold. Those are the facts. In the fact table, these are the facts: dollars sold, units sold, and then dollars cost. So these are the three facts. Those are being identified for this particular use case. So hope you had understood this particular dimension table, the fact table, and then the whole complete designing of the star schema. Then there is another example given over here. You can see financial ledger fact is placed in the middle, that is the fact table. Likewise, you have accounting period dimension, fund dimension, account dimension, organization dimension, activity dimension, and then project dimension. Wherever you want to establish the relation, we had identified the primary key, and then that is been placed in the fact table as the referential integrity, that is the foreign key. And then other than those, in the financial ledger fact, we had identified the facts called as budget amount change and then actual amount change. So these are the two monetary values, those come across as in the form of the facts. Likewise, you can go through the third example over here. Project dimension is given, investor dimension is given, account dimension table, currency dimension table is given, time dimension is given, and the fact table is fact investment, wherein which the facts identified are the investment amount, investment currency, total number of investors, total amount invested in the project, and then percentage of profit target. So these are the facts, those are being identified, and these are the reference keys over here. So these are the references that we had I had used for this session. You please go through. Hope you had understood the topic of dimensional modeling, especially the way that we had designed the star schema. With this, I hope you had understood this particular session. In the next session, let us discuss the snowflake schema. With this, I end the session. Thank you.
Do you wish to be part